Welcome to HP Tuner's GM Gen 4 Training Part 6. In this video, we're going to be taking a look at the Gen 4 PCM logic operation. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and talk about our GM Gen 4 logic operation. So our logic operation is going to be essentially how the ECU thinks. It's going to be how the GM engineers, when they designed the ECU to control the engine, how they programmed it. It's going to be running on a math modeled equation. And it's actually really simple the way we can kind of break this down and to look at the overview of how the logic operation works. We can definitely make it a lot more complicated. There's a lot more math crunching going on in the background that we don't need to know. We don't need to do that math crunching. We just need to supply the ECU with the correct information when we're doing our tuning so that it can use the information to calculate things such as our air mass and our engine torque so that the desired result is going to, again, be an engine that's going to start up properly, it's going to idle properly, we're going to have great drivability, and when we go into wide open throttle conditions, it's going to be delivering the torque and the power that we want. So let's jump into the first part of this video and take a look at that basic equation of how this logic operation is going to work, and then what we need to know about all the other tables that are going to be falling in line under that equation. Okay, so let's take a look now at this underlying equation that the ECU is always constantly modeled by. We're going to be finding its fuel mass is equal to air mass divided by our desired or target air fuel. And this is going to be the way that most mass airflow based ECUs are going to be working, or volumetric efficiency based fuel strategies. We're going to find that we have our mass if we're talking about fuel mass or air mass. Now the fuel mass is going to be the volume of the injectors that we're using, so how much they flow, multiplied by the density of the fuel that we're using. So if we're on 93 octane petrol fuel, or we're going to be on something like E85, we're going to find they have two different density amounts. Also, as the fuel temperature changes, we're going to find that it's going to have the density change as well. So that is all mathematically modeled in the GM ECU. Now when we look at the side of air mass, we're going to find that's going to be the volume of air entering the engine, and it's going to be the density of the air entering an engine. So depending on if the air temperature is really cold, we'll find that the density goes up. If the temperature of the air goes really hot, on a really hot day, 100 or 120 degrees, the air density will go down, and that's going to be affecting the air mass entering the engine. You can think of mass as just how much volume that's flowing in of a fluid, and then how many molecules are packed into that volume. That's going to be probably the most simplistic way to kind of keep this in the back of your mind. So when we're looking at this equation of fuel mass is equal to air mass divided by our desired or target air fuel, we'll find that the fuel mass